Hi Pre-Calc gang, it's time for our last lesson in Chapter 5, the law of cosines. And again, this is a method used to solve some oblique triangles with given conditions. Here's the law of cosines right here, as you can see. Looks a little complicated with all these letters, and sometimes it does get a bit confusing. Sometimes I like to rewrite this a bit. And again, primarily remember that the law of cosines is used for side angle side conditions and also side side side. Those are the two main conditions. Now, as I said, I kind of like to think of this rather than worrying about the A, B's, and C's, especially with a side angle side, that it is the opposite side squared equals the two adjacent sides. So adjacent squared plus adjacent squared minus 2 adjacent times the cosine of your angle here, whatever that angle would be. Sometimes it's a little bit easier maybe to remember it like that rather than to get mixed up with all the A's, B's, and C's. But either way, you should be able to do well with this. Now, here's another variation of the law of cosines. If I solved each of those for the respective cosine A, B, or C, and as we'll see, sometimes this is kind of important when we're trying to find the measure of an angle. Again, this gets a little confusing, but I think you'll be able to keep it straight if you draw a nice diagram and label it appropriately. So here's our first example here. Let's take a look at this. So this is solve triangle ABC if A is 39, B is 12, side B is 12, and side C is 14. So I'm going to try to draw this out here a little bit, best I can. So we have triangle ABC like this, and angle A is going to be the 39, so it's going to be right here. Side B is 12, side C is 14. So clearly you can see we have this side angle side situation. And if I want to solve it, I need to find missing sides and missing angles. So first of all, I'm going to try to find side A. And so here's, I'm going to start then with A squared. And that's going to be my two sides that I'm given, which is 14 squared plus 12 squared. Those are my two adjacent sides that we had a couple slides ago. Minus 2 times 12 times 14 times the cosine of that angle that they give you, which is 39 degrees. Nice thing about the law of cosines is you can just plop all this stuff right in your calculator. Just be careful when you do calculate all this stuff on the right side. Some people stop here, but remember it is A squared, or that value squared that we have here. So if I do this and take the square root, I will get 8.9. So that's what that side A is. Now if I want to solve this, so I still need to figure out what one of the angles is. So I'm going to change colors here a bit. And I am going to first of all try to find that angle C there. So the cosine of C, and again when I do this I just work with my adjacent and sides here. So my two adjacent sides are going to be 12 squared plus 8.9 squared. That's this side right up here. And then I'm going to subtract that opposite side and square it, so that's minus the 14 squared, and then divide it by 2 times my two adjacent ones again. 2 times 8.9 times 12. And when I do that, I get a weird decimal like 0.127. That's not your angle, remember, that's the cosine of that angle. So I need to do that inverse cosine of 0.127, inverse cosine of that, and then I'll be able to get that C is about 82.7 degrees, and I can subtract the sum of 39 and 82.7, 180 minus those, and my final angle then that I'll get is angle B, which is 58.3. Again, you should probably do this yourself just to verify that you're getting these answers as well. So that's a good practical application, well maybe not so practical, but an application of cosines. Now here's another situation where we could use the law of cosines, but we're going to introduce you to another formula called Hero's formula. This is a way, again, of finding the area of a triangle if you're given all three sides. And so in this particular case, notice that the way to find that is we find this thing called the semi-perimeter. Kind of strange, but basically that is adding the lengths of the three sides and taking half of that, so half of the perimeter basically, and then when we apply it to this formula, that'll help us find the area. So let's actually try this and see what we can come up with this particular problem here. So we have triangle ABC, gives you the three sides there. So first of all, let's see if we can find that semi-perimeter in this case. It's obviously going to be 0.5, and then the sum of all those will be 47 plus 53 plus 44. And if I calculate all that out, I will get 72. So that's my semi-perimeter. So then the area of this triangle will be the square root of 72 times 72 minus 47 times 72 minus 53 times 72 minus 44, like that. And when I calculate all this out, again, you can kind of verify this yourself. I do get 978.6 square units because this is an area. So that's a bit of a variation or an offshoot of that law of cosines that helps me find that area of that particular triangle. So, everybody, and just to leave you with a little thought, here's a couple pigs, but this is the old trigonometry farmer here that we have. So this first pig is called Swine, and his partner here is called Coswine. So that's the pigs of the trigonometry farmer. All right, thanks for watching, everybody, and we'll see you guys in class. Bye now.